Let's get started. Thank you for coming here. I know it's hard work being here for 2 days, and thank you for staying here with me. I think we'll have more time for Q&A session. First, let me introduce myself. My name is Shan. I'm with Alibaba Cloud. I work on blockchain technologies. So for my presentation today, I'm going to talk about blockchain as a service and how it works on Kubernetes. And I'm also talking about the challenges that we come across. First of all, the agenda. The core part of my presentation is item 3, the key problems and our solutions for them. First of all, a brief introduction of blockchain and BaaS. I'm sure you all have some understanding for blockchain. You've listened to Li Tong and Henry already. What is blockchain? In a narrow sense, it is a distributed shared ledger based on smart contract, and all parties of a transaction need to reach a consensus, and the transactional history is tamper-proof. And then apart from the technological side, there is a broader perspective to approach it. We think blockchain is more like a structure, architecture, or collaboration model connecting organizations, individuals, and machines throughout which network values can flow. What is BaaS? It is, in our belief, it is a blockchain platform service on a cloud platform. It offers deployment, maintenance, and governance for blockchain systems, and it can help you to manage and operate blockchain applications. So that's our understanding for BaaS. Here, we believe there are several types: public chain, private chain, consultant chain. The first one is like traditional IT architect. A private chain is a new centralized topology. The second type is a totally decentralized system, like public chain and other similar systems and models. Organizations and individuals are gathered on an open blockchain network. The other is a multi-centered system, an alliance chain. Comparing them, we believe there are 3 core differences, especially for the second 2. With access control, public chain and alliance chain, they're open, anyone can join. For the alliance chain, only approved parties can participate. In terms of privacy, they have different protections towards privacies. And there's a governance model and how you manage it, basically. Based on these analysis, here at Alibaba Cloud, we focus more on the alliance chain for corporates. Next, we're going to talk about why combine blockchain and Kubernetes containers. I listened to Li Tong talking about their experience. That was highly inspiring. We believe blockchain applications have some common features. First, with the system itself. By nature, it is a data-centered, highly distributed system. Data center means that the ledger, the transaction data is core. Highly distributed means that in different availability zones, it can cover different cities, different countries, highly distributed. So the full match connected so that different nodes can sync their ledger data and consensus for transactions. It's a long-running process instead of on-demand temporary operations. So it is a complicated system, and it delivers a complete solutions or systems. And then coming to the applications, There's no set standards. We might find various types of applications supporting businesses like web application, data service, stateful, unstateful. So that's for its application. If combined with Docker, we will get a standardized packaging and distribution model, guaranteeing that no matter how complicated the software is, no matter how many dependencies there are, there's one set way to package them and then deploy. Then it gives a consistent environment so that it can run anywhere, which serves for better portability. So that's the advantages of combining it with containers. Blockchain with Kubernetes, it offers a lot of advantages for resources, network, maintenance, stateful, unstateful support, microservice architect, seamless integration, safety segregation, community and ecosystem. That's why we came to KubeCon, because of these advantages. Here I wrote microservice architecture or service mesh. For a blockchain system, how can it be integrated? We've done some analysis for the blockchain system itself. Internally, there's a strong coupled architect, and the services are not universal. There are codependencies. So the blockchain system doesn't work that well for microservices, but the application itself naturally works great for the architecture. The diagram here shows the history of Alibaba Cloud in terms of blockchain. Last year, in 2017, in October, we launched the container service blockchain solution, which enabled many module-based one-step deployment. So within 1 minute, we can deploy a network for a corporate. And then in December, we transited from deployment, we migrated to Kubernetes. So we were able to build and orchestrate the applications. Towards end of July this year, we launched a BaaS that's supporting the version 1.2, which naturally works on Kubernetes, offering BaaS. This year in September, we launched the Yunxi meeting in Hangzhou that our BaaS supports the Ant Financial's blockchain. It is also available on Kubernetes. So that is the Alibaba offering in respect of blockchain. This is a clearer picture of our offerings. At the core here, there's platform as a blockchain as a service, BaaS. At the bottom level, it is the Alibaba Cloud service, and then there's security auditing, maintenance, smart contract, user management, and certificate management, etc. And in the middle, there are two engines, Hyperledger Fabric, that shows our support for the open source blockchain community. And then there's the Ant blockchain. So there are two engines. On top, based on SDK, there are multiple solutions and their implementations. So that's our product offerings. This is the cloud service for Kubernetes. This page here shows when you provision with BaaS a fabric-based alliance chain, the architect should look like this. For the fabric topology or the peer, you're already familiar. So there are several types. We support a cross-region consumption network. So different business organizations can be located in different regions and countries. At the left side, it is a alliance admin. It offers Orderog, Kafka, Zookeeper, Audra, and their peer in CA. The other participants can find the nearest location and deploy their peer organization and eventually join in the consortium. So it is a cross-region network. Peer and CA and Nodera, they are Kubernetes service. As for blockchain applications, it is deployed on Kubernetes, but it can also be deployed in other environments as well. Kubernetes, there's SLB or no pod, depending on which services there are within the organization. And then the third part, combining BaaS and Kubernetes and the problems that came with it. In the morning session, I've heard about many colleagues talking about similar challenges with packaging, service orchestrating, etc. Blockchain or BaaS by nature is a complicated system. It includes many containers, a fabric network. There might be 2 organizations and 4 peers. There will be more than 30 containers, more than 20 services, more than 10 images. So that's a lot of volume. And one headache is that the service has strong dependencies. When you deploy, the orderer needs to wait for Kafka to be booted, and Kafka needs to wait for Zookeeper. And different peers, MSPs, they need to wait for MSNTRs, waiting for the generation of the secrets. So there are strong interdependencies. So we've designed several solutions. With building and orchestration, we use the Helm chart. So for the KBaaS YAML, we can orchestrate them. And the binaries use the container image, that's normal. And the chart repo, we're using the Ali OSS object storage. For image storage, it is with the container registry service. So the chart repo, chart museum will also be added. In terms of configurations, because of the complexity of the system, there are many configs and secrets. So we use the config map to store fabric networks. And then the secrets will keep passwords, port secrets, safety-related things. The chart value can take inputs from the users, and with chart value, we can customize Helm chart. In the past, Helm chart is worked for the whole fabric network. Later on, we divided them into smaller granulars, PR, one chart, so it's separated, more flexible. In terms of service orchestration, first of all, chart template, defining the YAML, etc., and then the chart hook for some pre-deployment and post-deployment works, and then the init container and the internal shell script to test the readiness of the services. For example, the liveness and saneness of Kafka and Zookeeper. And then the HA. This is not just the development testing for the developers, but also production-ready service for corporates and businesses. So we need to think about HA. There are many facets to it, and here's a breakdown. At the bottom level, well, it relies on the cloud infrastructure and the resource service high availability, including the multi-AZ, the ECS, network storage, etc. On top of it, there's the BaaS management components, HA. If it's a single point, arrow. And then Kubernetes cluster, HA. There are master nodes and worker nodes to guarantee the HA of cluster nodes. And then the fabric components, the order, the peer, they are mutual backups, and then there's Kafka cluster, Zookeeper ensembler, and then CA itself can be a cluster. So these are the components HA guarantee. One thing to note is that how do we connect the availability to the Kubernetes? Between different peers, there are complete ledgers. If one peer goes down, the other peer can go up. We can sync the ledgers. But if the two peers are scheduled to one worker node, and then you lose the HA guarantee.
Here we have used port and key facilities. It can ensure the HA can be set on each of the nodes that you can use it. This is combining the two features together. As for the block applications, if we want to have a good HA design, then the enterprises or the clients should have a good HA design. But when it's interacting with the fabric, we should also provide some of the HA capability, because if they will first get access to the node port, this is health checking insurance. If there is any problem, then they can turn to other nodes and transfer to port, because this will include the discover. Maybe you connecting to the connection profile, maybe some of it is done, but on the channel you can collect some of the available services. This will help us to better access the fabric services and provide the HA guarantee. This is the HA design on different levels. And next, and there is a key point that many friends has talking about recent days. That is digitalization, including some keys, certificates, etc. The simpler way is local disk. Maybe first we should remove those that it's impossible to be put in the containers, because it's not physical, so it will easily get down. Otherwise, even you have good HA design, it will be useless. In Kubernetes, it has a calling function. Originally, maybe the peer can be related to the drivers, and then it will drift it to another on-premise nodes. And if this node is not on-premise, then that will have some problem, because the peer will have some HA capability to solve that. There are other possibilities. Maybe we can use the node data to solve that problem. For example, all the nodes has failed. Then on our discover, we have a more reliable driver to recover to my original status. So we have selected two approach. First, in the file system, there is a storage there and also the block storage as well. That, for example, the cloud disk. One of the features of it is that for the enterprises, this can provide very high availability, and considering also from the perspectives of the features, because it have better I/O performance as well. In the Kubernetes service, persistent volume and the PV and also the PVC is common. It's very common to us already. Although we've already used some storage, but for the ledger, there is a problem. And this ledger cannot be deleted. Along with the growth of the enterprises, then the ledger it will grow at the same time. So at first, if you don't have enough storage for it, then how can we address this problem? And we know that there is seamless dramatic scalar. For this scalar, it's transparent for the applications. The application would not be disrupted and don't have to restart. So this would be very friendly to the users. From another perspective is the features. Maybe we've already have a 100 gigabyte data of this ledger. And when it grow bigger, will it reduce its features? So when it grows bigger, it can grow together with the features, and it can have better features improvement. And this is some description of the fabric. We will use a cloud disk and also different allocation situation of the cloud disk. So just now we have talked about the storage. Let's get to the networking, consortium networking for enterprises blockchain. This field is actually what they focus on, because in the real conditions, it's impossible for us to put it into VCP. We need to think about the the consortium networking. There was some existing plan already. Maybe you can bring the nodes of different organizations in the VPC and communicate in the VPC, and also to provide a description of different nodes. And because it's a centralized structure, so it cannot show the features and capability of different enterprises. It can also satisfy the basic demands. And for example, the communication of different major network, they have different clusters, and through the UBS communications, it can satisfy their common communications. As for the for those like key enterprises that have very high confidential requirements, like the government and also the banks, then maybe they will think about the security. And also for the financial companies and institutions, they will, if they can pour a lot of special lines through the telecommunication operators. If different enterprises have take different carrier, different operators, if they want to form a consortium, how can they connect each other? That will have very high cost. If they have formed the original enterprises network, if there were new enterprises want to enter, then there will be a threshold and also require very high cost as well. This is not a perfect solution. And the existing like Ali Cloud will offer some of the solutions and products. We can combine it with BaaS to provide a consortium networking solutions for our clients. They can connect different VPC on the network. Then this is a kind of network solution that connecting different nodes, and through they can communicate through the internal networks nodes. Although this nodes is not existing on the on-premise database or not on-premise, they can connect to the VPC, and also together with the on-cloud VPC, they can communicate. Then that is a hybrid cloud that is across different enterprises and different accounts. It's not just providing IP to different attendees. They can provide descriptions of different domain names, like previously shown as well. That is a cross-VPC domain name services. So all of those clients and users who want to get access can utilize this. And implementation, which also think about this, the planning, the VPC and session organization to avoid the conflicts of the names, the namespace, or the names. So this is based on our experience. Next, let's focus on the chaincode, because the smart contract is based on chaincode, operated by chaincode. In conclusion, the chaincode container, because it's within the container and its life cycle. And here, peer, when they get the instantiate chaincode, then they would like to find a Docker daemon. And through the Docker daemon, through the Fabric CZD 4.1 image, then we can build up environment and also compile in it the nodes or goal and the other chain code, all the other chain code inside. And after they get the binaries, then they can pass it through the Docker daemon. We will generate a Fabric OS-based image with chain code, with my chain code banner, and then I will start it. Then this will become a started chain code container. We will find some problem in it. As for Docker daemon, because it's relying on Kubernetes host. So this would be implemented by the host Docker daemon, including some of the containers. It's actually separated and segregated from the system of the Kubernetes. As for the life cycle management, that will cause some problem to us. The second point is that because it's segregated from the Kubernetes system, it's difficult to use the namespace of the Kubernetes to do the segregation and also the other policy description or definition features to protect its network. And it's difficult for us to avoid some of the attacking access from the external network. And we'll also explore some of solutions for these problems. The first solutions is that I think this one will be more ideal. Maybe we can put this container in Kubernetes as a pod and put it into the Kubernetes systems. Then we can realize that then for the Fabric, no matter in which formats, then it can have a united formats and mechanisms to manage it. And also you can have the united standards to control the chain code access. However, this is really ideal, but the reality is that although the Fabric has this requirement, but recently we haven't realized this part. But we still think about whether it's possible to move on and thinking beyond chain code container for chain code container, whether it's possible to put it into the Kubernetes service environment, because different containers is sharing the same core, and the chain code is very important, especially for some sensitive code. If I put it in the service environment, like elastic and highly segregated environment, then they can have a kernel level segregation to protect the chain code. So that is one of our expectations. And another option is that whether possible to do the Docker in Docker, the DIND approach to do that. We also do some testing to evaluate this option, and we have used some Yelm and use this DIM. You can have a look at the code. Maybe you cannot see it clearly here, but in my PDF online, you can download it and have a look at it. The advantages of it is that they don't have to rely on the host nodes or the Docker socks or the Docker daemon to generate the Docker container, because for Docker in Docker, you can call it from Docker in Docker. And for all the chain code image in CCVV or from the host nodes have some with the dev prefix. If you have some chain code with the same name, then they will have some conflicts. But in the Docker in Docker, then you don't have the problem of the chain code names, because all the chain code name image is in the Docker in Docker environment, and this DIND they are going to clear up. So that is very convenient for us. But whether there is some limitation here, we can see that after we establish the tier, or when I want to restore some tier, I will find out that the speed is really low and sometimes it will be time out. Because in the chain code compiling environment like DIND, We want a fabric CNCF image. The image is very big, no matter it's the life cycle, the start of the life cycle, or during the compiling. The time will be very long.
And the life cycle of the DND can be very brief. Unlike in traditional methods, the fabric semi image, once pulled, it's put in the worker node, and then you can use it forever. And then the chaincode extensor becomes slower. That's understandable because in DND there is a lot of operations, and then that can use up the performance. And then when you reboot the PM node, there can be problems. One also very important thing is that in practice, DND approach is often used in CI/CD, testing, and continuous integration, etc. But for production environment, there can be many challenges with the stability. That is why we haven't used it in the production environment. And then the DID doesn't solve the segregation and safety issues with the chaincode. And then what we're doing today, a workaround, I should say. With configurations, we get to satisfy the core demands. For example, guaranteeing the communication between peer and chaincode, and with the YAML environment, the core configurations can guarantee the peer and chaincode communication. And by using Docker RM, Docker RMI, we can manage the lifecycle based on script. For the afterwards clearing, we can use daemon set, and then lifecycle pre-stop exit command for cleanup after delete. Or maybe we can use the init container before. When we guarantee the communication between peer and chaincode, we can customize the IP table rules limiting the access of the chaincode container. For example, access to external websites. And by far, we have realized a safe control and catering to our core demands, but in the most ideal case possible, we would like to go along the first option. Nowadays, BaaS have helped many of our clients in and also outside of China have some applications. For example, product traceability, protection of digital copyright, and supply chain finance, and also data asset sharing. Because of the limited time, I'm not elaborating on that. Here are some of the basic patterns of the blockchain system on Kubernetes. The application development itself is not difficult. With BaaS or any other means, you can come to an alliance chain across businesses. And then there's the VPC interconnected. And then your blockchain applications with your backend database can have a communication, maybe enabled by PVC. It is very simple. So no matter if it is a blockchain system application, we can use Kubernetes as a foundation. Here's a simple demo showing what BaaS can do today. First of all, at the BaaS portal, we are going to fast build a cross-enterprise, cross-account consortium. And then we send the link to another business, inviting them to join the consortium. It's being deployed across different regions. Once they finish creating the new organizations, they are able to join the consortium. Once the admin gets the application, it gets approved, and that's the enterprise communication. And then we can build a new channel, including all the businesses into the same channel. Since there are many enterprises, and we need certain approval process and invitation mechanism, So there's approve and accept. And once we build that channel and consortium, there are usernames. Here's a text message verification, SMS verification, because we need risk control to make sure that we don't lose millions overnight because of a simple mistake. And then they need to download an SDK. And we also need to download a demo, MAPO, and SS transfer. This is the connection profiles automatically generated. The demo and the development applications cannot use it. After you finish the local deployment, you upload the chain code to the dashboard and then install it. Using and endorsement, each party needs to install the chain code and then coming to instances. This is a high-risk operations because each chain code might have implications on the business, so we need risk control. And then we operate, or we run the model connecting the chain code in the prod environment. Once we're connected, we see the chain code being deployed on it, and then on mobile we get to build the virtual assets, the colorful marbles, and then as you can see, the blocks are any number. Each time you create and ship and delete, the chain code at the bottom level is invoked. Because of limited time, I'm not finishing all of this. We need to introduce you to our homepage, and please let us know what you think. So much for my presentation today. If you have any questions, please let me know. If no, well, I'll be here anyways. We can discuss offline. Thank you very much.